Okay, so this is solving inequalities. Solving inequalities. An inequality is different from an equation. An inequality is a statement comparing two quantities that are not always equal. That are not always equal. All right, so I think you guys have seen these symbols before. You would have had it probably 6th grade, maybe before. And I'm talking about these symbols right here. So I'm always interested in how you learned how to know whether it's greater than or equal to, less than or equal to. What did you learn that the symbol is? Kristen? An alligator. I've heard the alligator before. So it's an alligator. It's eating up things. What else have you learned? I have heard it. How many learned alligator? That's what you learned. All right, so that's most of you. Anybody learn anything else? Edward? The moose. Okay. I'm sure you learned that. What teacher taught you that? Give me their name. A moose, huh? It's a new one. All my 30 years of teaching, I've never heard of a moose. She must be an outdoorsman or outdoors woman. Her husband must be a hunter to think of moose. All right. Moose would fit. That's okay. Anybody be taught anything else? Omar? A bird, all right. I guess a beak of a bird eating something. Christina? A dolphin, all right, I guess. Dolphins do have big mouths. Anything with a big mouth would kind of fit. Anybody actually know what it is? Wrath? Arrow. It is an arrowhead. The symbol's an arrowhead. So the first symbol there, which way is the arrowhead pointing? To the left or to the right? Left. To the left. On a number knot line. What happens to numbers when you go to the left? Do they get bigger or smaller? Smaller. And that's the reason this one is a less than. Right? The arrowhead points to the left. So you guys are used to figuring out based upon numbers. And it's not too hard to figure out what the symbol is when you have a number eating another number. But what if you have two variables? What if I gave you a problem like this? What if I just gave you the symbol with no numbers and nothing and said, what is the symbol? And now there's nothing to eat, and you got to know whether it's a less than or equal to, greater than or equal to. So the second one, the green one there, points to the right. And on the number line, as you go to the right, what happens to your numbers? They get bigger. That's why this is a greater than. The symbol is an arrowhead. Okay, when we put the line underneath, that's half of an equal sign. And it signifies or equal to. So the left one points left, so it's a less than, and the line says or equal to. So it points left, so it's less than, it's got half the equal sign, so it's less than or equal to. And then, of course, that fourth one points right, so it's greater than. And it has half the equal sign, so it's or equal to. Okay, so let's first learn how to graph them, and then I'll talk about a little bit more about what inequalities mean. But don't forget it's an arrowhead, and if you do, you shouldn't have any trouble knowing whether it's less than or greater than. Numbers get smaller to the left. When the arrowhead points left, it's less than. Numbers get greater to the right. When it points to the right, it's greater than. And I will ask you that on quizzes and tests to make sure you know that, because you can't get that mixed up. Okay, to graph. To graph the solution of an inequality, Isolate the variable on the left. Now, when we solve equations, not an inequality, an equation, does the variable always have to be on the left and the answer on the right? And the answer is no. Sometimes we could solve it with the variable on the right and the answer on the left. For an inequality, can you solve it with the variable on the right? You can, but the answer is less understandable. And when people go to graph it, they'll usually get the graph wrong if they put the variable on the right and the answer on the left. So the best way to do it, the safest way to do it, the way to be correct most of the time is if you'll solve it with the variable on the left and everything on the right. Okay, so we have a couple situations. What if the symbol does not have the line underneath of it? That's the first example. That's what I'm trying to show you here. You don't need to circle that. But notice these two symbols don't have the line underneath. So whenever you're graphing a less than or equal to, you put a circle over the number, over the quote-unquote part of the solution. I'll show you what I mean in a minute. So if we had, for example, n less than 5, we would put a circle over the 5. If we had an n greater than 2, we would put a circle over the 2. All right, what if there's a line underneath? Then you put a dot over the number. I'll show you this again in a moment when we do some. But a circle is open. That means the number below it's not included in the answer. But a dot is closed. That means the number below it is included in the answer. And I'll show you that in a minute when we do that. But here's the thing about an inequality. You don't get a single number answer. You get a set of answers. For example, let's suppose we had the problem n greater than 1. Can somebody give me an answer to that inequality? N greater than 1. N greater than 1. Nia. 4 is an answer to that. Okay? Because 4 is greater than 1. Can somebody give me another answer? Edward. 3 is an answer because 3 is greater than 1. Give me another answer. Juliana. 8 is an answer. Colby. 2 is an answer. Christina. 5 is an answer. Chloe. 6 is an answer. There's a lot more answers yet. Ashley. 7 is an answer. Come on, think outside the box. Allison. 101 is an answer. How about 5.2? Is that an answer? Yes. How about 11 halves? Is that an answer? How about 1,000,000? Is that an answer? How about 57 billion? Is that an answer? There's an infinite number of answers. Matter of fact, any number bigger than, what was my original one? I don't even remember anymore. Whatever the number was, okay? So we have to show that by using an arrow over all the values that are the solution. So if the symbol points to the left, then the arrow points to the left. That's pretty easy to do. Hey, but class, by the way, that's if you have the variable on the left and the number on the right. If the symbol points to the right, then the arrow points to the right. The arrow goes the same way as the symbol is pointing. Okay, let's see if we can put this into practice. So the first example is n greater than -3. Now I need you to pay attention closely. The book wants you to do this. Instead of putting the circle or the dot above the number, the book wants you to put it on the number. So -3 is right here. Don't do this. They want you to put the circle right there. And then, because the arrow points to the right, our arrow would go right here. The problem is, normally we're in pencil, and we're doing everything in pencil, and that becomes hard to see. So I always have my students to do it above. So we want to put a circle above the -3, and that you can do in your notes. And now I'm going to take my green, and from that circle, my arrow goes to the right, the same direction as the inequality symbol. Here's what I'm saying. Any number, even if it's not shown, that's below my green arrow is part of the answer. So, is -2 part of the answer? Yes. Is -1 part of the answer? Yes. Is 3.7 part of the answer? Yes. Is a million part of the answer? Is a googolplex part of the answer? Yes. How about this? Is -3 part of the answer? No. That's because what's over the -3? An open circle. Is -3 greater than -3? No. So -3 isn't part of the solution. So open circle, anything just bigger than -3 is part of the answer, and that's how yours should look. All right, let's go below to the one below it. Y greater than or equal to 0. So what do I put over the 0? A circle or a dot? A dot, because the 0 is included. And my arrow points the same way as the symbol, to the right. Because isn't every number underneath part of the solution? Is 2 greater than or equal to 0? Yeah. Is 4 greater than or equal to 0? Yeah. Is 1 greater than or equal to 0? Yeah. Is a million greater than or equal to 0? Yeah. And you need the arrowhead, because remember, it keeps going forever, to infinity. Not beyond. It does. But it does go to infinity. Christina.
It don't matter where the arrow stops.
The arrow doesn't stop. It goes on forever. We can't show you a line forever, though. So we have to stop it, but the arrowhead tells you it goes on forever. This line goes on forever to the right. This goes on forever to the left. Our answer goes on forever to the right. The same direction it's pointing, in the greater than direction. Okay, don't let something like our third example up here to the right get you scared. I hope you know where to put 3/2. If you don't, change it to a mixed number. What mixed number is 3/2? 1.5. Do you know where to graph 1.5? Do we put a dot over it or a circle over the 1.5? A dot. So find 1.5. Look, this is the 1, right? So 1.5 has to be, right, between the 1 and the 2. So dot over the 1.5, arrow to the left. Should have done it in red there. Keep my color coding. Arrow to the left. Don't let a fraction get you down. Change it to a mixed number, and away you go. Ooh, what is this symbol? What is it? Okay, is not equal. So x is not equal to -3.5. How would we graph that? Anybody know? Raph?
Circle, then lines going each way.
Okay, so circle over the -3.5. This is a -3, right? So -3.5 is halfway between. Circle over the -3.5, arrow to the right, arrow to the left. The arrow goes both ways. Because let's try a number here to the right. Is it true that 2 doesn't equal -3.5? That's true. How about a number here? Is it true that -4 doesn't equal -3.5? Yeah. Matter of fact, every number is the answer except for -3.5. That's the only one that's not the answer to that. So our arrows go both ways to infinity and beyond. Kristen. Then it would be everything except 3.5.1. All right, these are solved just like equations, except So if we know how to solve equations, we can solve inequalities with one exception, and you can't forget the exception. Now, I usually like to take some time here and get us to realize the exception. So I'm going to go down here to the second one. You guys can go to your notes, go to B here. All right, so let's take a look at B. Come on. Let's go ahead and solve B. By the way, for inequalities, we always want to solve with the variable on the left. All right. Things added to the variable, you move by adding their opposite to both sides. You always do that first. Things multiplied times variable, you move by multiplying both sides by the reciprocal. Okay. We're going to solve this. Oh, Windows 10. So the first thing I want to do, Windows 10, will you stop? I want to add a -4 to both sides. Agreed? My next line will be -2x less than or equal to 4. Is that agreeable to everyone?
Yeah.
Okay. We can do the shortcut, and now I can divide both sides by -2. Agreed? That gives me an answer of x less than or equal to what value? -2. Okay. So that's our answer, x less than or equal to -2. Now, let's think of some numbers that are the answer. So, somebody raise your hand. Give me a number that is part of the answer. Colby?
-47 million.
-47 million. Let's go a little closer to -2, although Colby is correct. Juliana? -4. Because I want to see if what we got is true. So do you agree -4 is less than or equal to -2? Okay. Let's put -4 into the original. Now, you don't need to do this. I'm going to do it. You watch. -2, and where the variable is, I'm going to put in the -4, right? We've done that before, right? Substitution. Okay. -2 times -4 is a +8. Agreed? 4 and 8 is 12. Is 12 less than or equal to 8? Is 12 less than or equal to 8? This is false. What happened? We don't have a true answer. We used a number that was less than or equal to -2. We put it back in the original, and we have a false statement. The inequality is broken. And we did a right thing. We moved the thing added first by adding its opposite to both sides. And we moved the thing multiplied by multiplying by the reciprocal, or doing the shortcut, dividing. But the answer is not true. And look, we can try every value less than or equal to -2, and none of them will work. Here, I'll do one quickly. Let's do -3 instead. Don't do this, just watch. -2 times a -3 is a +6. 6 and 4 is 10. Is 10 less than or equal to 8? No, that didn't work either. What in the world? We're wrong. Can you fix it?
Yes.
We need to fix it. We need to make it work. And I'll give you a hint. Here was the problem. The fact that we had a -2 times the x. If that would have been a +2x, we wouldn't have to fix anything. It would work beautifully. But listen now, the multiplier of the variable is a negative. That's when we have the problem. So how can we fix it? How can we get from the wrong answers to the correct answers? Nia? All right, then don't raise your hand. I'm asking for thoughts. How can we get from the wrong? We got to fix it. How can we fix this, Colby?
Use -2.
Well, that's only one value, and that only works because it's an equal to. If it would have been a less than, it wouldn't even work then. And we need all the values that are the answers, not just one of them. But at least you're thinking, and that is true what you said. But I need to get all the answers, all the solutions. I need all the answers. Can somebody give me a number that does make it true? Raph? 8. So Raph says, if I put 8 in here, it'll come up true. Negative 2 times 8 is a negative 16. 4 minus 16 is a negative 12. Is negative 12 less than or equal to 8? Oh, Raph is correct. An 8 would have worked. Anybody know another number that would work? Christina? 7 works. Anybody know another? Anybody know another? 6 works. Anybody know another? 5 works. Anybody know another? 4 works. Another? 3 works. Another? 2 works. Another? 1 works. Another? 0 works. Another? Negative 1 works. You got another? Negative 2 works. You got another? Negative 3 doesn't work. But negative 1 worked, 0 worked, 1 worked, 2 worked, 3 worked, 4 worked, 5 worked, 6 worked, 7 worked. Guess what? 8 will work, 9 will work, 10 will work, 11 will work, 12 will work, 13 will work, 14, 15, 16, 17, 18. I can go on forever. 20, 40, 80, a million, 2 million, a billion, they all work. Can you fix it? It takes one little thing to fix it so the answer is correct. Right now, this is where you're focusing. That answer is wrong. We need to do one little thing to make the answer correct. And remember, we just figured out that negative 1 is part of the answer, 0 is part of the answer, 1 is, 2 is, 3 is, 4 is, 5 is, 6 is, 7 is, 8 is. Nia?
Change the less than or equal to sign to a non-equal sign?
What, just flip it? Like that?
Well, no, not like that. I mean, words.
Well, isn't that what you said?
No?
All right, say what you said again.
Change the less than equal to sign to where the sign says x is not equal to negative.
Well, that would include values like negative 5, negative 10, negative 4, ones that don't work. So how are we going to fix it? Can anybody fix it? So how do you say values that are negative 1, 0, 1, 2, 3, 4, 5, and up? How do you say that? Nia?
Greater than negative 2. X is greater than negative 2.
So you want to flip the symbol like that?
No, greater than that.
That is greater than. I just flipped it around. It's pointing to the right, right? Is right bigger or smaller? We just made it x greater than or equal to negative 2. Is negative 1 bigger than?
Yes.
Is 0 bigger than? Is 1 bigger than? Isn't that what you just told me to do? You're the one that told me. Right? Didn't you tell me that? See me after class. So this is the answer. That's what you do. That's what you got to do to fix these. All right, so let's go back and write it, and then I'll show you a few more of them. If you do it at the wrong time, though, you will get the problem wrong. All right, these are solved exactly like equations, except I use the word reverse. Students like to say flip. Reverse the inequality symbol if you multiply or divide by a negative quantity. But this is the only time you reverse the inequality symbol. If you multiply or divide by a negative quantity. Not add, multiply or divide. All right, I'll show you what I mean. Let's do a few. This first one's pretty simplistic. Add a negative 4 to both sides. You get rid of this, we'll come back to it in a moment and do it normal. Okay, so we add a negative 4 to both sides. I now have 3n greater than 9. Do I flip my symbol? No, because I added. I didn't multiply or divide. I'm going to divide both sides by 3. Agreed? Do I flip my symbol? No, because I divide it by a positive, not a negative. Final answer, n greater than 3. Now, if I had time, I'd go back and show you. Well, I'll do a quick one. Do you agree that 10 is greater than 3? So put 10 where the n is. 3 times 10 is 30. 30 plus 4 is 34. Is 34 greater than 13? Yeah, and all of them work. So how do you show that as an answer? What do I put over the 3? A dot or a circle? Circle, because the 3's not included. And the arrow points to the right. And those are all the numbers that are the solution. Hey, 3 doesn't work because 3's not greater than 3. But 3.1 works. 3.001 works. 97 is true. 1,000,000 is true. 10 zillion is true. All right, so here is the written answer. Here is the graphed answer, right? Written and graphed. So here's that second example. So again, things added to the variable, you move by adding their opposite to both sides. We know how to do that. We get negative 2x less than or equal to 4. But watch what I do. Take your green. At the point when I divide both sides or multiply by a negative, I right then reverse my symbol. And I'm telling you, if you don't remember to do it right then, you're going to forget, you're going to have the wrong answer. And guess what most people miss when solving inequalities? They forget to reverse the inequality symbol. Again, I'm dividing by a negative quantity. Now the left is x, and the right is negative 2, and that's what we just found were the correct solutions. How do I graph this? Dot over the negative 2, arrow to the right. Again, if you were to go back and try all those values in the original, they would work. They would work. All right, so again, let's keep good habits of solving equations or inequalities. There's always a left side and a right side. Normally it's the equal sign in the middle. Now it's the inequality symbol. We're either going to add things to both sides or we're going to multiply or divide both sides. We're going to isolate the variable. We're going to get it by itself by moving stuff away from the variable. You guys are great at that, almost every one of you. So, class, what do you do to C first? Tell me what to do to both sides first. Just say it. We're going to add a negative 1 to both sides. I agree. So now we have negative 3y over 2 greater than negative 5. Negative 1 is a negative 6. All right, somebody raise your hand now and tell me what to do on this next step. Hannah?
Multiply both sides by 2 over negative 3.
Okay, and we want to do anything else? Help her out. What else do we do, Brendan? Yeah, do it as soon as you multiply by a negative, or you're going to forget. Because we multiply. Look, this is what we did to both sides, right? This is a negative quantity, and we reversed our symbol. Again, this is going to move the negative 3 to the other side. This is going to move the 2 to the other side, leaving the y all by itself. That's what we're after. What are we going to do on the right? We're going to arbum, right? We're going to reduce before we multiply. Hey, negative divided by a negative is a positive. So what does the right end up being? 4, right? It is a 4. So our answer is y less than 4. How would we graph that? Circle over the 4, arrow to the left. Circle over the 4, arrow to the left. Okay, so if you look at D, a little bit more complicated. And by the way, can we do some with the variables on both sides? Yeah, we know how to do them already. What would you do? Get all your variables on one side, just like we did with equations. But remember, you only reverse the symbol when multiplying or dividing by a negative quantity. So you look at D. Wouldn't we distribute first? Don't we know how to do that? So you can do it, I'll do it, you do it at the same time. If you need to look. But you try to do it. And then when you're done, see if you can graph it. Hopefully you didn't flip your symbol, right? Nothing called for us to reverse our symbol. Did you change it to a mixed number to help know where to graph it? Right? It's a 1 5/6. So here's the 1. So I have to go 5/6 more. Somewhere approximately in here. I don't need to put all the marks. Circle over that. Arrow to the left. Okay? We are 5/6 of the way towards a 2, right? We're almost to the 2. If we had one more sixth, we'd be at 2. That's the concept, that's the idea. Okay, let me show you a couple special situations. Come on, go away. All right, special situations. If sides of the inequality are swapped, we call this the symmetric property. In that situation, you must reverse the inequality symbol. So look at A. A starts out with the 7 on the left and the n on the right, correct? If we put the n on the left and the 7 on the right, we must reverse the symbol for it to stay the same thing. We've got to reverse that symbol. For example, 7 is greater than or equal to n. So what if n were 0? Would this be true? Is 7 greater than or equal to 0? Is that true? Yes. Right? Is 7 greater than or equal to 0? Okay. So we should be able to put 0 here and see if it's still true. Is 0 less than or equal to 7? Yeah, they're the same thing. We're writing the exact same thing. This and this mean the exact same thing. The difference is on the right, the variable's on the left. Because here's what happens. I'm going to give you a problem like B. And I'm going to tell you to graph -3 less than A. And everybody that's smart is going to say, I'm going to put the variable on the left and the number on the right, and I'm going to flip my symbol. And everybody that doesn't remember to do that's going to get the problem wrong. Because now we know to put a circle over the -3, and which way does the arrow go? Right. Remember, we know the way the arrow goes when the variable's on the left. So just swap it. Whenever you flip sides, you've got to flip the inequality symbol. Here's one other situation. How about C? We're not solved, right? Remember I taught you always solve for the variable being positive? So here's technically what you do. You divide both sides by a -1. And because I divide it, what do I do to the symbol? Because I divide it by a negative, what do I do to the symbol? I got to flip it. I divide it by a negative. I get x greater than -5. Here's the shortcut. If you ever have a negative variable, change it from negative positive, switch the symbol, and change the sign of the number on the right. The number on the right is a positive 5, so it'll end up being a negative 5. If the number on the right would have started out at negative 5, it would end up positive 5. And that's a shortcut. If you don't like the shortcut, divide both sides by -1 and the math will take care of it for you, okay? So if you don't like the shortcut, just do the math and it'll take care of it. All right, I got to real quick do 4 variables on both sides. I think you only have time to watch, so don't worry about it. Just watch. If you try to write, you're not going to keep up. 12 plus 6x. Don't pack up. Watch. Plus 3 greater than or equal to 2x plus 5. Add like terms. 12 and 3 is 15. Get all my variables on one side. I always move my variable from the right to the left, whether it's positive or not. 4x plus 15 greater than or equal to 5. Agreed? Move the 15. Add a negative 15 to both sides. 4x greater than or equal to negative 10. Divide both sides by 4. Do I flip the symbol? Do I flip the symbol? No, I divide it by a positive. Don't get that mixed up. Reduce negative 5/2, and that would be the answer. Hey guys, don't get mixed up of when you reverse and when you don't. That'll kill you. Make sure you only reverse when you're supposed to. All right, you see your homework. Make sure on the odds you're understanding what you're doing so you're ready for an evens and quiz tomorrow.